the Chinese remainder theorem. Okay? 对不起，我的中文不好. I'm just saying, my Chinese isn't that good. Bu hao means not good. You all know ni hao. That's you good. You good? You good? Ni hao. And bu hao is not good. Here we have bu jisho. This is not known number, unknown number. You probably learned this as wei jisho, but this poem is from 1700 years ago. Or, well, more than 1,000 years ago. Okay, so it's bu jisho. And this is a poem, right? It's 6 characters, 6 characters, 6 characters, 6 characters. So there's an unknown number. When you divide it repeatedly by 3, you get 2. When you divide it repeatedly by 5, you get 3. When you divide it repeatedly by 7, you get 2. What's the number? Okay? When you see 3 lines, that's 3. When you see 2 lines, that's 2. 5 lines. The upside down 7, that's 7. Okay? So there's an unknown number x. When counted in 3s, we have 2 left over. When counted in 5s, we have 3 left over. When counted in 7s, we get 2 left over. What's the number? Okay, so this was problem 26 of volume 3 of the mathematical manual by Sun Tzu, Sun Tzu Xuanjing. Okay, the mathematical manual written by Sun Tzu. Okay, in China it's called the Sun Tzu theorem, or sometimes they call it the Chinese remainder theorem. Okay, this first 2 characters, that's China, center, country. If you're in China, then China is the center, right? If you're in Canada, then Canada is the center. Everything else is far away from us, right? So center, country. That's the Chinese remainder theorem. Okay, how many people know this? The Art of War, the book Art of War. Philip, you know it?
I mean, I've heard of it, but I've never read it.
Yeah, okay. There's 2 non-Chinese people in the last class that knew it too. Well, you've heard of it from the last class. So.
No, I have the book.
Oh, you have the book, okay. This is written by Sun Tzu. The mathematics manual is written by Sun Tzu. It's not the same person. They lived 765 years apart, approximately. Okay? It's a common misconception. A lot of people think that these 2 books were written by the same person, but they're not. 765 years difference. Okay, so Sun Tzu explained how to solve the problem. He noted that 70 is congruent to 1 mod 3 and 0 mod the other moduli. 21 is congruent to 1 mod 5 and 0 mod 3 and mod 7. 15 is congruent to 1 mod 7 and 0 mod 3 and mod 3 and mod 5. So x equals a multiple of 70 plus a multiple of 21 plus a multiple of 15. In this case, we have 2, 3, and 2 as the multiples. We get 233. You plug 233 into that problem and you get that it satisfies all the conditions. So any multiple of 105 is also divisible by 3, 5, and 7, right? If I take 3 times 7 times 5, the product is going to be divisible by 3, 5, and 7, right? And if I take 105, which is the product of 3 times 7 times 5, and I multiply it by an integer, whatever that number is going to be divisible by 3, 5, and 7, because it was created that way. So 233 solves the problem, and then if I subtract a multiple of 105, I will get 23, which is the smallest positive answer to this problem. Okay, this might have been fast. This is the way it was written in the book. Well, okay, it's translated, but this is basically what Sun Tzu did between 200 and 400 AD, so 1700 years ago, right? 1,700 years ago, approximately. Okay, so this is the Chinese remainder theorem written in the course notes. If n is congruent to a1 mod m1 and n is congruent to a2 mod m2, then if we find one solution to this system of congruence relations, we can find the general solution. We can find that the general solution is congruent to that particular solution mod the product of the moduli.